All right. Hopefully you can all hear me now, right? And I need to actually share the presentation so that you can all see that as well. There we go. All right. Here we are. Here's David Minnick to introduce you.
Good evening, everyone. Welcome to the April 2025 meeting of the Oregon Archaeological Society. Our special guest speaker tonight is Dan Stueber. Dan's career in archaeology spans 4 decades and has been marked by a devotion to understanding flint knapping and lithic technology. He worked at Archaeological Investigations Northwest for 16 years as lithic technology specialist. He has taught flint knapping and lithic analysis classes and workshops for regional universities, state, federal, and tribal government agencies. He has been a member of OAS since 1981 and served on the board multiple times. Since 2015, he has been collaborating on archaeological research projects focused on the earliest inhabitants of the Great Basin and the Columbia Plateau. He has provided lithic analysis for the top researchers in the region, including Dennis Jenkins at Paisley Caves, Pat O'Grady at Rimrock Draw Rock Shelter, Richie Rosenkrantz and Caitlin McDonough at Conley Caves and Cougar Mountain, and Lauren Davis at the Cooper's Ferry site in Idaho. As a result, he has authored and co-authored numerous publications and book chapters. His contributions to the field were recognized at the 2023 Great Basin Anthropological Conference, and they had a symposium in his honor. Julia jumped ahead of me here, but I wanted to also point out that the Society for American Archaeology has just announced Dan will receive this year's Crabtree Award at its upcoming national meeting. He will join a previous OAS recipient, and that is George Poets Chat, who won it about 10 years ago, I think. Dan's topic tonight is understanding stone tools through experimentation and replication. Please join me in welcoming our good friend, Dan Stueber.
Can you hear me at home? I mean, in the Zoom land?
Yes.
Yeah.
All right. So, okay, great. Well, thank you all for being here this evening. Julius, do I use this mic for wandering?
For wondering.
Just one.
Yeah.
That's hot too. I think.
Yeah.
Thanks for coming this evening, and thank you all all you in Zoom land, as if I can see them. I'm happy to be here and talk about what I love to talk about, lithic technology. I first gave this talk at the University of Nevada, Reno, a couple of years ago by invitation of my colleague there, Jeff Smith, and I'm happy to get some more use out of it tonight. As a bit more of a self-introduction, many of you out there, I know that you know I've been a musician all my life, but I'm a drummer and percussionist. But I had always had a fascination with prehistory. And before my wife Nancy and I, who's my wife right there, before Nancy and I moved to Oregon in 1981, I was trying to teach myself how to flint knap. And so we got here, and Nancy got a job at OMSI when it was up on the hill next to the zoo, and told me the Archaeological Society met there and I should go to a meeting because I was kind of geeking out, you know. And I went to a meeting and I walked in and there was John Fagan flint knapping. Well, I latched right onto him. And so he became a teacher and mentor. And I worked with him a lot, and I worked with him at field schools at Melchior, and we did flint knapping, attribute analysis, and lots of experiments. And when he and Joe Reese opened Archaeological Investigations Northwest, they asked me to come on as the lithic analysis specialist, which I did for actually 25 years until 2015. And I worked closely with my colleague, Terry Osbin, who's sitting right there. We had many wonderful discussions on why did it break like this, et cetera. This evening, I'm going to talk about some of the questions that can be answered through lithic replication and experimentation using examples of projects that I've been involved with. First, I don't want to echo too much. I think I am. What is lithic replication? Well, lithic replication is to make as closely as possible a copy of an original stone tool using the same methods and tools that were used by the people that produced them. So how do we approach replication? Well, we're informed in different ways. We can get clues from the debitage that we might find associated with a tool we're interested in that can help us reconstruct the process. From tools that we find in different stages of manufacture, and from completed objects, and you just have to sort of reverse engineer it to figure out how it was made. Experiments, most stone tools that are recovered through excavations and surveys are broken or used. And so to understand what they've been through, we use tools, cutting, scraping, and hide work, et cetera, throwing them with little darts, seeing how they work and break, shooting bows and arrows, and just using tools and experimenting with them. And so the projects I'm going to talk about tonight use or do all those things. The first one I'm going to talk about is my work with Dr. Arad Callahan. In 1982, John Fagan introduced me to Callahan, who was a world-renowned flint knapper, experimental archaeologist, and replicator. And I had the opportunity to study with Callahan for many years. Arad was let's see if I can get to slide on.
We're good.
Mhm.
Oh, I think it's upside down.
Oh, it's upside down. Well, duh. There you go. Arad was the first person to replicate the Type 4 Danish dagger, which is considered to be one of the most complex stone tools in the world. That's a picture of that dagger. I'll get this down. Okay. That's a picture of the dagger, the Hundskull dagger. And it's a Danish national treasure on display in the Danish National Museum. And it is truly magnificent. If you go to Denmark, go and see it. So in 1994 and 2000, I organized 2 workshops for Arad to teach here in Oregon. They were both focused on the dagger production, the Type 1 and the Type 4. The 94 class was the Type 1 dagger, and the 2000 class was the Type 4 and Type 5 daggers. The Neolithic period of Northern Europe from 6500 to 3800 BP was marked by agriculture, farming, and the establishment of large settlements, long-distance trade, and the production of more advanced stone tools, such as various types of daggers and axes. The latter part of the Neolithic period in Northern Europe overlapped with the Copper and Bronze Ages in Southern and Eastern Europe, where ores for the metals were available. It's there where metal daggers were first made, particularly bronze daggers, were created by casting. And the metal daggers were traded and made their way north to Denmark, and the Danish flint knappers saw an ideal opportunity to make their own daggers. So they started copying the bronze daggers, particularly bronze, some copper, but mostly bronze daggers in flint, thus beginning 600 years of the dagger period from about 4,400 to 3,800 years BP. Let's see. So I turn this around again. What's happening? Do I keep turning this off? Where am I supposed to aim at? Here.
I bet you, I just go ahead and try it now. All right.
Okay, here we go. The six basic daggers from the dagger period, the 600-year dagger period. Type 1 is, okay, let's go back here. Okay. There's the type 1, the type 4s, and type 5s, all copies of metal daggers. Here are 4 views of the Hundsvall dagger, the one that Eric was most interested in. And I'll talk a little bit about it. Wait, I'll learn to do this in a minute. Okay, here you go. Here you go. Here's the top of the dagger. Side view, you can see how the handle gets thicker. Here's the base or the pommel, and the back of the dagger. All copies of daggers that look like this. What's complicated about this is that the blade, or this part, the biface, is biconvex. The handle is a triface, so it's got 3 sides. It's a triangle, as you can clearly see from the pommel. And these elaborate flaking around the edges is called stitching, and it was made to replicate stitches that were on the leather that wrapped the handles of the bronze daggers. So they were pretty amazing stone tools and a really early market-driven competition. Let's see. So in 2002, Eric invited me to be one of his dagger apprentices. So the mission of our apprenticeship was to replicate the daggers, record all aspects of their production and the debitage. And it was interestingly, an ancient workshop where these daggers were produced had never been found. The case of replicating it was reverse engineering it, figuring out all the stages, of which there are about 8 stages in the production of a type 4 or type 5 dagger. From our experiments, flakes from all stages of production were analyzed and recorded, and the study was undertaken to help Danish archaeologists identify debitage from dagger production workshops if and when they find one. and to facilitate Eric's book, Neolithic Daggers, Volume 2, which is there on the, you can page through it later. Okay. Next project is the Mesa site. And Mesa site is located above the Arctic Circle in Alaska. It's a high mesa surrounded by a flat plain, and it has from the top of the mesa where the site is, you have a 360-degree view of the surrounding plain and the herding animals. It was occupied on the late Pleistocene to the early Holocene from about 11,600 to 9,900 BP. Evidence from the site on the top and in association with caribou remains recovered on the adjacent plain. It was determined from the evidence found that there were two hunting strategies: hafted bifacial points and slotted microblade points. There, hafted bifacial, these are the mesa points, and these are the microblades. Jacob Adams, a PhD candidate from Washington State University, was doing his dissertation on aspects of the mesa site and asked me to replicate 120 mesa points for his research. 40, yep. That's what I said when he called me up. What? And when do you want these? 40 obsidian, 40 chert, and 40 rhyolite, and 120 microblades, 60 obsidian and 60 chert. These were all the same materials that were being used at had been used at the site. As is often the case with students writing their theses or their dissertations, his timeline was kind of short to get his experiments done. So he needed all the points in a couple of months. So I enlisted my friend Steve Halley, a great flint knapper from Central Oregon, and we made 60 each of the mesa points, and I made all of the microblades. So the drawing on the left are drawings of the mesa points from the site, and on the right, the first 5 that I made for this project. Here are the 120 points that when Steve and I were finished, and I sent these to Jake for his work. It was interesting that Steve worked on his, he lives in Sisters, and I worked on mine at home in Portland, but when they were done, and he sent all his to me so they could go in one group, except for our etched in initials, you couldn't tell the difference between the points, which Jake was very happy about. So we were quite consistent with our replication of the points. Here are the microblades on the right, 120 microblades that I sent to Jake, and on the left, microblade cores. And there are some there on the table. You can look. These are the leftover rejects that didn't get sent to Jake, and some of the exhausted microblade cores. So Jake's research questions were about caribou hunting strategies. Why were there 2 different hunting systems being used? Bifacial projectile points and slotted microblade projectiles. Did it have to do with hunting solitary or herding animals? Was hunting done in winter, and how would Arctic sub-zero temperatures that can get to -70 Fahrenheit or below affect stone projectile points? Would one of these point projectiles function better than the other seasonally? So the biggest research question was, are the projectile points affected by sub-zero Arctic temperatures? Here's a couple of the slotted points hafted in antler. Jake chose to use just two microblades per slotted point. I think he was a little rushed because the originals had 4 or 5 on each side. And here is the beginning of the experiment. There's 3 of the hafted mesa points. So 60 of the points were frozen to -70 or -57 degrees Celsius. They were one by one put into a bath of liquid nitrogen until they got down to temperature. Then they were shot with a crossbow into a set of ballistic materials made to replicate going through a caribou. So he did, and 60 were done frozen, 60 were done at room temperature with the microblades, 20 room temperature and 20 frozen. And here's the results. Not too much damage. The obsidian 10 obsidian broke, but 8 broke that were warm. And as you can see, there wasn't a lot of difference. I think in the end, if you read his dissertation, and if you want it, I'll send you a copy and you can read it. But he thinks that the real difference was hunting, herding animals with slotted microblades and solitary animals with bifaces. That was his what he came up with from his long analysis project. Next project I'll talk about is the Cooper's Ferry site, Nipahey in Idaho, 16,000 years dated to. Most of the Cooper's Ferry points were found in several cache pits at the site. One of Dr. Davis' students, Sarah Skinner, an MA, that was writing her MA thesis to investigate the question, can point resharpening be identified? Excuse me. High-resolution 3D scanning would be used to show how the curvature and shapes of the points changed as a result of resharpening. This information would be one way to determine the use life of the points found at the site. So I was asked to replicate 30 Cooper's Ferry points, make a photographic record of all the reduction process, and collect all of the debitage from the production of each point. I'll point out before I go off of this slide. There's Cooper's Ferry Point at the juncture of Rock Creek on the Salmon River, and it's right there. There's a campground. It's a great place to camp because there's a campground down the road. The site is now covered over with asphalt, but there's a really nice panel that talks about the site there. Oh, the second slide. This is funny. The second slide is what what the site was like at glacial maximum. This is the Cordilleran ice sheet and the Laurentide ice sheet, and there's Cooper's Ferry right there. So here we have on the left all the points from pit feature 1. There was a cache found there, and on the right were my replicas. Lauren gave me, he did an average of point sizes and gave me that, and so I was to within about just a few millimeters. I had to make all the points within a certain size range for this experiment. So it started with removing flakes from cores. Everything was photographed, and smalls were photographed. And here's a picture of my napping kit. I used for making I didn't really use the billet much at all in this work. I used these larger hammer stones to remove these smalls. And for making the Cooper's Ferry points, I used this hammer stone. I made all of the early stages of the points with this hammer stone, and I finished it with this and this, 2 pressure flakers. There are attributes on the original points that suggest that they were resharpened in the haft. And I'll point that out right now. These little protrusions we call hafting ears, because as Lauren and I had discussed it, it looked like they might have been left over if the points were sharpened while they were still hafted or in their foreshaft to be efficient. It's a very efficient way to resharpen them. And so that's one thing we wanted to test, to see if hafting ears happened if during the process. So I had to come up with a hafting element that we could easily take the points in and out of, because after they were resharpened, Sarah had to scan every one of them, and there were 30 points. So I would use bone. I would cut bone to dull the points and getting ready to resharpen them. And then once I was finished resharpening a point, I would hand it to Sarah. She would take it out of the haft another one, while I would be resharpening a second point. And we had to do that 30 times for 30 points. And here's a picture of me at work. Resharpening in the haft, and you can kind of see right here where I keep hitting the wrong buttons. Right there is where the point meets the haft. And in fact, after our experiment, a number of points ended up with those little ears, because when you got down to the wrapping of the foreshaft haft, you couldn't take the last couple of flakes to get right to the shoulders. The overall research was very time consuming for a number of reasons. I replicated and resharpened all the points at my workshop in Portland. Sarah was living and going to school at OSU in Corvallis, about 90 miles drive each way. High-resolution 3D scanning was used to capture details that you can't see using any other measurement devices. So in order to do this, each of the 30 points had to be first dusted with powder to reduce the shine. They used Tenactin athlete's foot spray. They found that to be the best. I know, I thought that was funny too. Then it was mounted on a rotating platform for scanning at OAS Then Sarah brought the 30 points back up to me in Portland. I rehafted each point, cut them, dulled them with bone, resharpened each one. As the point was removed from the haft, like I said, Sarah put another one in. When 30 points were finished, Sarah took them back to OSU to be scanning. And we did that 3 times. The scanning time alone took 150 hours. So it's really time consuming. But here is just one of the points. If anybody's interested in her master's thesis, it's really interesting work. And I think a predictive model that we can use for predicting how many times the points might have been resharpened. But you can see this point right here. Oh, I keep doing that. Okay, that's the original point, and you can see the edges changing. And here it is laid out from after the 3 resharpenings. Each resharpening is a different color. And here are the slope changes of the edges. And here in the side view, you can see how the point changes. And her thesis has all these images for all of the points. And it was quite a fun and interesting project. The next one I'm going to talk about is flake removals for obsidian hydration. This project was neither experimental or replication-based, but rather a tool for taking minimally destructive obsidian hydration samples. In recent years, tribal cultural resource personnel have stopped giving permission for obsidian objects to be cut for obsidian hydration analysis. So, anybody not familiar with obsidian hydration here? Okay. Obsidian, interestingly, absorbs water at a very slow rate. And if you can get a slice or a piece out of the obsidian and look at it at 500 power magnification after it's been prepared at a hydration lab, it's a pretty tedious and complex technique. But when you look at it 500 power, you can see what they call the hydration rim, how far the water has gone into the obsidian. And it's a relative dating technique, not exact like carbon-14, but you can get relative age, particularly if you have large collections to deal with. And then there are hydration rates that are figured out, but it's a very, very useful tool. And so over here, you can see the cuts. And tribes didn't want us to do this anymore. And I and many of my colleagues agree that it's destructive and it really messed with the integrity of the points. So on the right, there's a photo of me removing a flake. Pressure flaking removal isn't a new method. Terry and Osmond and I did projects, I don't know, 20 years ago, removing some flakes it was done back then, but people it was easier to get them cut. Now they're not allowing cutting. So it's going to be the new way forward. To date, I've removed over 400 flakes for hydration readings from obsidian objects from Oregon and California. And presently I'm on a team that's developing this method for the state of Idaho. Okay. Yeah, here's one, a concave base point that I've just taken a flake from, and there's me mugging for the camera in the center. And on the left, three black rock concave base points from California. On the left side, they are before flaking. On the right side, a flake has been removed. I take my diamond tip scriber and I mark a little teeny weeny X where I've removed each flake, so it can be, so where the event happened. Okay, the last one I'm going to talk about today is projectile point measurements. Actually, projectile point measurements are often used to classify points into specific types. David Hurst Thomas's 1981 publication, How to Classify the Projectile Points from the Monitor Valley, has been an important resource for archaeologists and university students when doing analysis of Great Basin Holocene projectile points from about 10,000 years BP to contact period. In 2021, cultural resource representatives at the University of Nevada, Reno, requested that the university no longer allow students to use cultural objects for analysis purposes. So Jeff Smith, my colleague professor at UNR, asked me to replicate the 10 projectile point types from Thomas's publication and to make 5 of each of the 10 types, totaling 50 points. The five for each type would I've made them all slightly different because they're in this measurement system. There's a range within each type of measurements, if measurements mean anything to you. And that's another subject. But anyway, here are the replicas on the left here. The original ones that I sent to Jeff when I was finished. Here's the chronology of oldest to youngest. And once they were done, Jeff asked me if it would be okay to have these cast at one of the lithic casting labs. So I agreed, and they're available on special order from Ocquan Paleo. It's a casting lab in Virginia, and there are about 10 universities that are using these replicas now because, it's happening all over. Tribes just don't want people to use their cultural objects, and I understand that. And so this is a good way that replicators like myself can help them with good replications of objects. The only way that I differed from Thomas's Monitor Valley report is that he describes a point type called the cottonwood leaf shape, which are very small bipointed projectile points. We don't have those in the Northern Great Basin. We only have cascade points, a lot of cascade points. So Jeff asked for just cascade points and forget the cottonwood leaf shape. So if you ever read the Monitor Valley report, you'll see what I mean. So these are just a few of the projects that I've been involved with over the years, and it's been, for me, very informative and just a lot of fun. So I have a number of people to thank, and references. If anyone is interested in any of the references, let me know, and I can, if you don't have access, I can email you any of these dissertations or whatever. And thanks for listening.
Well, can I ask questions?
Yes, okay. Questions? Anybody got any questions?
All right. What material was used to cast those points?
Oh, it's an epoxy resin. They can get so amazingly accurate. I've got dozens and dozens and dozens of lithic casts that I use for teaching examples. And some of them can match exactly the original stone. Mike can do that with his cast, but he didn't. There were so many, and then to do this in an efficient way, he had to do 5 casts on one mold. So he had 5 points in one mold. So he used mostly black, and as you can see, well, I'll just go back to my originals. Yeah, as you can see, there are a number of different obsidian types and different types of stone that I used. But they can be replicated. It's quite amazing how good they are at casting. There are a couple of great casting labs in the country. Any other questions?
Question.
Yes, did they also make projectile points using agate, and what did that stone making techniques have to be changed or modified for harder stones?
Oh, you mean heat treatment?
Heat treatment or agates, like for agate?
Oh yeah, sure. I think you're talking about heat treating. Yeah, that's a good question. Some of the cryptocrystalline stones like flint or chert, agate are too hard to work in their natural state or to do fine work anyway. And so about 100,000 years ago, somebody figured out how to do it. In Africa is the earliest evidence of heat treatment of stone. So prehistoric people have been doing it for a long time. They cook it very slowly, heat it up at a slow rate, cool it at a slow rate, and you change the crystal structure and it makes it glassier. Yeah, I've cooked a lot of stone. I know Terry's cooked a lot of stone. Dennis Torsdal's cooked a lot of stone. Any flint napper who's serious about it has heat treated stone. You can do it at home simply with one of those turkey roasters. Put sand in it and your flakes, put it in, turn it up 50 degrees an hour until you get it to 350, 400 degrees. Let it sit there for a few hours, turn it off and let it cool down until you can reach in, pull it out. That's heat treatment. Yes, good question. Hey, Dennis.
With laser points, with chart, heat treatment?
No, it was all raw material. The tough one, good question. The tough one was the rhyolite. When Jake asked me to do the project, I talked to Steve Ellerly about it, and I said, "Hey, what's rhyolite?" He said, "I got a great rhyolite source." So there's up out of Madras, about 10 miles out of Madras, in the national grasslands, there's a place where there's red and pink rhyolite, so that all those red rhyolite points. But that material is really tough, and you can't heat treat it because it's volcanic, and so that was a learning curve. So it took me a while to get used to not having flakes hinge off. So yeah, but you realize it was all in the platforms. You had to get your platforms right. So your platforms are you get your edges prepared just right to have enough force to drive the flakes across, and then you have to have a good technique.
Did you have to supply all of the materials for these projects, or
No, I did. I had a student from California a few years ago want me to make some of those Shumash trifacial drills. out of that Monterey chart. And I said, well, yeah, send me Monterey chart. I can't get that here, and I never heard from them again. So I didn't do the project. Terry.
Yeah, excuse me. I just wanted to say I've worked with Dan Stueber for more than 30 years. And he is probably the best flint knapper that I know. And I've known flint knappers around the world. And he's also one of the most widely experienced in different technologies around the world. And so he really knows what he's talking about.
Well, thank you, Terry. Terry.
My question is, when you were replicating the Monitor Valley points,
Yes.
there's been a long going debate about whether some of the different types are a result of resharpening or whether those are the types that were originally intended by the manufacturer.
Yeah.
And I was wondering if in your replication work, you discovered any relationships between the different types that you thought might either reflect that they're originally manufactured that way or that they're resharpening byproducts of some other type?
Well, that's a great question, Terry. I think the Elko ear and the Gate Cliff this one I forget the Elko eared and the Gate Cliff split stem are the real teasers, and when it comes to that. But you do see a certain amount of consistency within those, and from although we've always been bored on that sort of thing. Where's the cutoff line? That said, Jeff, this is a way that Jeff's been teaching this stuff in his Great Basin classes, and Thomas's paper has been a sort of a go-to for professors. So I had to just go with the flow, and but I can I think the big difference in his measurements where the angles of the stem part, where you get a wide flare with the Gate Cliff, with the Elko eared, and a much less flare and the split stem. So I can see that when I replicated them, there's a bit of a difference, and Thomas's measurements account for all that. So how valid is it? Some of those things we might never know, and they overlap in time. And then the other thing you have to account for is different nappers. No two nappers can make something exactly the same. Yes.
Distinction in skills. Can you look at these original pieces and go, oh, that person had it?
Oh, yeah, certainly. And I think that's a great question. You can, and I think the biggest one is identifying novice snapping or people learning, because that, we're looking at prehistory, a time when nothing was written. And when we can go back and say, children were here. We know that because the evidence is here. And when I was working with Jeff Smith on the LSP-1 rock shelter in the northern Warner Valley, there's a monograph out. I worked on the lithic technology chapter. It's called In the Shadow of the Steamboat. And so if anybody or you are desert rats and know the Warner Valley, this is a great site, a rock shelter in the northern Warner Valley. And when I was doing the analysis, I saw a lot of evidence of novice napping, and Jeff was just blown away because in his analysis of the rest of the site, lots of rabbit bones, like 30,000 rabbit bones. And he was assuming there were families there. And the evidence, kids being there, flint napping, just held that theory up. So And then, of course, you can look on the other end of the spectrum where some flint knappers are just like Eric Callahan. I worked with Callahan till he passed away, and 20 years probably. I watched him. I only ever saw him break one thing, and he was working in my backyard, and he was making a miniature Type 4 dagger. It was that big. And the handle broke, and he got really mad, and he threw it down in my debitage pile of all my flakes, and he stormed into the house. And I dove into that and looking for the parts, and I do have the blade, but that's the only mistake I've ever seen him make. You know, he was just amazing. And I know Flanagan was like that, although I saw Flanagan break one biface, but it was at a demo and he was using my hammerstone. He blamed it on my hammerstone. But, you know, yeah, there are some. Terry's a phenomenal flint napper. I mean, he's praising me, but I worked with Terry long. He's a phenomenal napper. And, you know, we just talked about, you know, we just geeked out on lithics for 30 years.
Got a question?
Yes.
Where do you get your raw materials for making all these?
Oh, different places. For Obsidian, Glass Buttes is a go-to place over 77 miles east of Bend on the way to Burns. It's BLM land, and you're allowed to take 250 pounds a year per person. But you have to seek out other sources of stone, you know, and once you get into knapping circles, you find out, you know, people say, oh yeah, you can get this here or that there. And now that there's so many more flint knappers than when I started flint knapping in the very early 80s, there weren't many of us around. And you can just buy really great stone on the internet from people who supply it, who live in areas. If you want flint, you can buy it stone from people living in Texas or flint-bearing areas or other. So it's obtainable.
How long do hammerstones and other tools last?
Oh, great question. Depends on who's using them. I was trained in the Western tradition of using sandstone hammer stones for working obsidian. And like I said in this slide, let's see. Wait a minute. Slide my toolkit, there it was. Okay. I made all of those Cooper Ferry points with just that one hammerstone. And since then, it's got a little flake off the back, but some of these I've had, this one, that's had some use. I've had that for a long time. This one too. This one too. This is spalled hundreds and hundreds and hundreds of, removed hundreds of flakes. So they last pretty long when your technique is good, but if you're hitting something wrong with them, they'll fall apart. So yeah, that to answer your question, it depends on your technique, really.
Those Type 4 daggers,
Yeah.
they look amazing, but were they real tools or were they just a showpiece? Like, look what I can do.
That's another great question. Some of them, many of them have been found, and they're called prestigious daggers. And having worked with Eric for so long, and he was pretty obsessive compulsive about the daggers to like the nth degree. So, and many of them have been found in pristine shape. So there are hundreds of beautiful daggers, Type 4 daggers. And so they think some of them were quite prestigious and they didn't get used much. But also there are daggers that are found with those types of prestigious handles, but the blades have been, or the cutting edge has been used and resharpened and they've whittled down. So, but many of them were really not used and people pranced around with them because they were only real specialists that made them, and they were probably pretty expensive to get unless you can make one yourself. And it was a real specialty at the time, you know. They still really haven't identified a workshop. You know, that's the big question. Where were they making these things? And the other thing is, they used copper pressure flakers to make those daggers. So because they were in an age when copper was available and copper got up there, that copper allowed them to do some of that real fancy stitching. It can be done without copper. It's harder to do though. And a recent study, a microscopic study, has found copper on the edges of a lot of the daggers. So that's been verified and not just a rumor anymore.
Okay.
Well, thank you all for being here and for the great questions.
Thank you.
Hey, Dan.
And
Dan.
we have some display up here as well.
Oh, yeah. I brought two of the things. All of Jake's things are gone and broken. Although he says in his dissertation, he hated to have to break them. And I have the cast from the Monitor Valley, a few microblades and microblade cores, and Eric's book and Jan Appel's book. Jan was, I didn't point him out, but he was one of the three apprentices for Eric's workshop. That's his book. It's a great book if you're interested in the Danish Neolithic. There's the Western stem points, and here's a book that I have a chapter in. It's on stemmed and fluted point technologies in the West. And here's my chapter with Darren Duke Haskett and its close parallels.
Don't forget, before I really close out for the evening,
Good question.
May 1st
Sure.
is Dr.
Hey,
Banks'
Dan, can anybody hear us?